Hey guys, we're going to do another video here for chapter 2. This is section 3 of our textbook if you're following along with that in class. And the essential question in this video that we're going to focus on is how can you use multiplication or division to solve an inequality? So chapter 2 in our classroom at least is really focused on what's an inequality, how do I solve them, and how do I graph them. And we've done some prior videos on this, but now we're really going to focus on when you have to use multiplication and division to solve. And I think most easy way to go about this is just dive right in, do some problems. So we're going to start with example 1 and we're going to try a problem. And here's the type of problem we're talking about today. We want to solve for x. And the situation that we're going to start with is solve x over 5 is less than or equal to negative 3. Then graph the solution. So x over 5 is less than or equal to negative 3. Well, I'm going to solve it just like I would a typical equation. I'm going to put a line down the middle, and I'm going to isolate x and get the variable all by itself. So I got to get that 5 out of there. And when I say x over 5, what I actually mean is I see a fraction. And fractions in algebra really mean division. A fraction means divide. So it's really x divided by 5 is less than or equal to negative 3. So to get rid of that 5, I'm going to go for the opposite effect. I'm going to use multiplication. So let's take that 5, move it to the other side, and times it to the other side. That gets rid of it so that x is all by itself. And we have our less than or equal to sign, and we know negative 3 times 5 would have to be a negative 15. So we've got our solution. There's our answer. X is less than or equal to negative 15. And now it's time to graph. So we're going to set up a number line. And because the number is negative 15, I'm going to be a little more thoughtful about my number line. In some of the earlier videos, I was always putting 0 in the middle and then doing my numbers. But if I do that on this number line, if I put 0, I have to go all the way back to negative 15, which I could count by 5s or 3s or something to make that happen. But I'm going to keep it a little simpler and just pick a spot on the number line to put negative 15, somewhere in the middle. And then I'll do a few numbers on the right. So I guess I'd have to do like negative 14, 13, 12, 11, 10, and I'll do a few numbers on the left. And then it's just a matter of figuring out which way to shade and do my arrow. Since 15 is my focus point, I'll circle it. X is supposed to be less than negative 15, less than or equal to. So the less than values are going to be the more negative numbers. So I'm going to draw a big arrow. I'm going to shade it off to the left towards the negative 16, negative 17, negative 18, and I'll make a big arrow pointing, saying it's going to keep going forever and ever that left-hand direction. I also know that because there's an equal sign, negative 15 is equal to negative 15, so I'm going to fill in my hole and make it a solid point on the number line. You can see it blinking there kind of as a reminder, but negative 15 has to be filled in. It's got to be a solid point. But then that's it. There's your number line, there's your solution, I've shown my work, pretty well organized, and we're done. Those are the type of problems we're going to be working on in this video. So let's try another one. Let's do an example 2. Here is example 2. We want to solve 6x is greater than negative 18, and then graph the solution. 6x is greater than negative 18. Well, put a line down the middle. Let's get rid of the 6. 6x means 6 times x. So we're going to do the opposite of multiplying. We're going to divide it away. Divide by 6. And we're going to do it on both sides. And I'm going to use a fraction for my division symbol. I don't want to use the line with the dot dot, the old, like the division symbol that you see on your calculator or something. Because a lot of times in algebra, we kind of avoid using that symbol. And we go for the fraction line instead. So I'm going to divide by 6. Get rid of the 6's. X is going to be all by itself. I'm going to take 18 and divide by 6, negative 18 and divide by 6, and I'm going to get negative 3. So x is greater than negative 3. There's my solution. All right. Now time to put that one on a number line. So I take my number line. This time I can use 0 in the middle because negative 3 is pretty close to 0. I'm going to go 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, all the way to negative 5. And then I'm going to circle that point that's important, which is negative 3. Now, x is anything greater than negative 3. So if you're testing points in your head and you're kind of thinking about it, when I test those points, here's some random tests that I can choose. I know that negative 5 is not greater than negative 3. I know that negative 3 does not is not greater than -3, it's equal to. But I know 2, yeah, if I test it out to the right, 2 is greater than -3, so I'm going to be shading off to the right this time with a big arrow. But leaving it as an empty hole. We're not going to fill in -3 because there's no equal sign. And that's it. There's my graph. We got it done. Okay, so you try. Let's do a couple problems here. I'm going to give you 2 questions, an A and a B, and you're going to give them a try, and you're going to pause the video and see if you can solve them yourself. Here are your 2 questions. This is a good time right now. Pause the video, copy them down, and you should solve and graph. So go ahead and give that a try, please. Okay, so this is now after you've finished both problems. You're unpausing the video. You have solved and you have graphed, and I hope you have them both done because I want you to see if you're getting them right or not. So, first one, line down the middle, we're going to isolate n. N was our variable by dividing the 3 away, and we're going to get n is less than or -4. And for the second one, we have m that we want to isolate. We got to multiply that 10 over and get that 10 away from it. So 10 times -0.5 is just -5. So we've got our 2 solutions. Here are the number lines. If you did your number line, this is what it should look like. For -4, you're going to have an empty hole shaded to the left. And then for m is greater than -5, it's greater than or equal to, you're going to have a solid hole shaded to the right. So hopefully you did okay on those. Kind of check and see if you made any mistakes. And I really hope you're organizing your work in that like step-by-step manner. Try to be organized. It's so crucial in everything that we do in algebra. Okay, so moving on. There are different types of these that I want to warn you about. So let's look at a new example. Example 3. Here's an interesting one. -8x is less than 24. Now, it doesn't look interesting. It looks like just the last 4 problems that we did basically in this video. It looks very similar. So I'm going to start off by just solving it regular. Line down the middle. We're going to get rid of -8. It needs to be away from the x, so we are going to divide it away on both sides. That'll get x all by itself, and 24 divided by -8 is -3. So we've got our answer. X is less than -3, but this is a weird case, and I'm going to show you why this is a weird case. This part's kind of strange, but imagine we decided that x could be -5. X can be anything less than -3, we just said. So anything less than -3, x could be. It could be -4, it could be -5, it could be -10, it could be -1,000. I'm going to pick one number that it could be, -5. And I'm going to test it because it should work. If I put -5 in for x as a test, it should pass the test. So where the x is, we're going to replace with a -5. We're going to do -8 times -5. And it should be less than 24. So -8 times -5 is a +40. Now is 40 less than 24? Did we make a true statement? And hopefully you're like kind of like scratching your head thinking like, what? 40 is not less than 24. This totally didn't work. So I'm going to put a little red slash through there. It's not true. And that's what makes this a weird case. If we had not checked our answer, if we had just stopped earlier and said, hey, x is less than -3, we're done. Our answer's incorrect. It doesn't work. And the reason for that is because we divided by this -8, which I'm going to explain in a minute. But watch this. If I was to flip the sign, if I was to flip the symbol and make it x is greater than -3, that would flip all of these signs. All the ones in my check would flip the other way. And now 40 is greater than 24, and now it's a true statement. So we have this weird case where we did our work and it seemed like we did everything correctly, but the test proved it was wrong. And that's all because we divided by a negative number. I know this is kind of strange, but it's called the flip the sign rule. You always want to flip the sign when you're multiplying or dividing by a negative number. That's something that I would recommend you memorize. You get that kind of stuck in your head. For some reason, when you multiply or divide by a negative number, if you don't flip your symbol, then your actual solution ends up being incorrect and it doesn't work. So the flip the sign rule, this is going to be a big key thing I want you to take away from this video. Anytime you're multiplying or dividing by a negative number, you flip the symbol. Now, I never showed you this when we were solving regular equations, because if you have an equal sign and you flip an equal sign, it's still an equal sign. It didn't matter. But with less than, greater than signs, it does matter. So let's look at an example that kind of falls into this category. Example 4. M over negative 3 is less than 2. That means m divided by a negative 3 is less than 2. So we want m all by itself. So we're going to take that negative 3 and we're going to move it to the other side. But we're moving it with multiplication. This is the flip the sign rule. We are timesing a negative 3 to the other side. And because we're doing that, this is what kind of clues me in that, oh, it's one of those flip the sign problems. So I know 2 times negative 3 is a negative 6. But usually I'd say this is my answer. M is less than negative 6, but not in this case. It's flip the sign, so it's actually m is greater than negative 6. That's my solution. So it's just, like I said, it's kind of this weird rule that you have to kind of remember, but multiplying and dividing by negatives makes you flip the symbol. And of course, I can put this on a number line real quick too. I'm going to put negative 6 in the middle of my number line, and then I'll do some numbers on the right and left, so like negative 5, 4, 3, 2, 1, and on the other side, like negative 7, 8, 9. And I'm going to circle the 6. M has to be greater than negative 6, so all the greater than values would be off to the right. And there's no equal sign, so it's got to stay an empty hole. I'm not going to fill that hole in with a solid point. So there's my number line. Now, if I hadn't flipped the symbol, my graph would have ended up drawing the arrow to the opposite direction. It would have been all the less than values, and it wouldn't have worked. When I actually tested a point, it would not have worked. So it's important that we remember the flip the symbol sign rule. Okay, so your turn, you try. I'm going to give you 3 questions, and some of them you might have to flip the sign, some of them you might not have to. You have to kind of figure that out yourself and graph the solution. So here is your first problem. Go ahead and pause the video, and when you're ready, we will check it. It is negative 5z is less than 35. All right, good luck. Okay, unpausing the video. Is this a flip the sign problem? Yes, I hope you're thinking in your head, yes it is. You're going to divide by negative 5 on both sides. You're going to need to flip the symbol. So your solution is going to be z is greater than negative 7. You're going to have a nice empty hole at negative 7 right there. That's empty, and you're going to shade it off to the right. That should be your final solution. Now my steps aren't shown here. I'm just showing you kind of like an answer key. But hopefully you have the line down the middle and you show dividing by negative 5 on there. Why don't you try another one? Here's B. Negative 2a is greater than negative 9. Go ahead and pause the video, solve and graph. Okay, so negative 2a is greater than negative 9. Time to check your answer. Again, this is a problem where you're going to divide the negative 2 away to the other side, and every time you divide by negative, you have to flip the sign. Also, negative 9 divided by negative 2, negative and a negative are going to turn into a positive. So your solution is going to be a is less than 9 divided by 2. But you could just leave it as 9 halves if you wanted. A lot of people like to switch it to a decimal, so you could say a is less than 4.5. Or you could say 4.5. Notice on my number line I've got the empty hole, but I also labeled it 2 different ways. I called it 9 halves and 4.5. You can label it how you wish. Like if you want to call it 4.5, that's fine too. But you should shade the right direction and you should still have the right correct value. Okay, one more. Letter C. X over negative 3 is greater than negative 4. Again, pause the video, go ahead and solve and graph. Okay, last one to check. So you've unpaused the video, you've got this one done. You put your line down the middle. You decided negative 3 needs to multiply to the other side. So it's again, flip the symbol. So x is going to be less than positive 12. Less than 12. Again, another empty hole at 12. Shaded to the less than value, so shaded to the left. And there's your solution. So you guys, we're wrapping up this video, and the big takeaway today, I hope, is that you remember that when you're solving these multiply divide problems, if it involves a negative number that is multiplying or dividing by, then you've got to flip the symbol. But if it's not a negative number, don't flip anything. Don't start flipping the symbol every single time you have a problem now. Only with negatives and multiplying and dividing. All right, guys, hope that helps, and there's going to be more videos. Bye.